Well, after I talk about the two methods of deriving multinomial logit model, I want you to pull back to uh, the concept of a minimum set of coefficients. I showed you that coefficients for some comparisons could be computed from coefficients for comparisons of other coefficients. For example, uh, the coefficient vector here um, for the odds comparison of laborer versus professional is equal to the coefficient vector of laborer versus skilled workers, and plus the coefficient vector for the odds comparison of skilled workers over professional. And here I'm talking about, same covariance, okay? So this equality does not hold for coefficients across different covariates. Here I'm talking about covariates corresponding to the same covariates. We can do that manipulation. Right? Manipulation. In general, if you have m outcomes, you can estimate a minimum set of coefficients from m minus 1 comparisons, odds comparisons, that will allow you to determine the coefficients for all possible comparisons. So, for example, I used throughout these slides is what occupational status, right? Skilled workers, laborers, and professionals. So we have three categories. And what is the minimum set of coefficients? 2, okay? As long as we have 2, we can derive the full set of coefficients for, all odds comparisons. And different programs will compute different minimum sets. This is not a problem if you know which set of coefficients you have. And for details, please see our lab guide. Well, the probability of y equal to m, as shown in one of our previous slides, is equal to this ratio in the numerator, is this natural exponential function of x beta, lowercase m, for odds comparison of lowercase m over capital letter n. Then in the numerator is 1 plus summation of a series of natural exponential function. Okay, natural exponential function. And if we let the beta vector of capital letter M over capital letter M for this odds comparison equal to 0, as shown, derived in one of our previous slides, then the probability of y equal to m can be re-expressed as this expression. That one can be absorbed into the summation, and this makes expression of a probability simpler, right? And the challenge now is how to figure out these beta coefficients, right? These beta coefficients. Well, since we figure out PI, that is individual probability, is the probability of observing whatever value of y was actually observed for person I, if the observations are IID, that is identically independently distributed, then the likelihood equation becomes this term, right? So the likelihood function is a product of this individual probabilities, And for each probability, as we just talked about, can be expressed in this way. And what comes next is to use what maximum likelihood estimation, right? And here we don't have closed form solution. We have to rely on numerical methods to find the solutions. And in the lectures on maximum likelihood estimation, I talk about two main tools we have using numerical methods, right? One is gradient descent. The second is Newton-Raphson or Newton-Raphson-like methods to find the solutions. There are also software issues involved. Different programs estimate coefficients for different minimum set of comparisons. If you assume that your program is estimating one set of contrast when it is estimating another, all of your interpretations will be incorrect. So you got to be careful which minimum set of coefficients your software program estimates.